Hello everybody, my name is Elliot Kimmel. I'm a high school science teacher and this is my tutorial on how to draw Bohr Rutherford diagrams. This is intended for students taking grade 9 and 10 science who are just starting out with chemistry and would like to know a little bit more about how to draw these diagrams. So let's get started. This is a scaled down version of the periodic table, which I'm sure that you've all seen. I've got the first 10 elements here, starting with hydrogen and ending with neon. This is how the elements are represented in the periodic table, and we have a symbol, we've got a name, and we've got some numbers. Let's have a look at what kind of information this can give you. So here's helium, and right off the bat we can see a large number 2 in the top left corner, a symbol, a name, and some other numbers here. The atomic number is in the left-hand side here, so this is number 2 for helium, atomic number 2. And by definition, the atomic number tells you how many protons are in the atom. Now, protons are the positively charged particles that are found in the nucleus. So if the atomic number is 2, that means there are 2 protons. Assuming that the element or the atom is neutral, and we're going to assume that for this tutorial anyhow, then if there are 2 positive protons, there have to be 2 negative electrons. Those 2 charges will cancel out, so there's no charge on the atom. So the atomic number also tells you how many electrons there are. The symbol is given here in the middle. The symbol for helium is capital H, small e. It's important to make the first letter capital and the second one small. The name is also given below, so He is the symbol for helium. Below the name is the mass number or the atomic mass. I like to call this the mass number though. And this is really the mass of the atom or the element when you combine the protons plus the neutrons. So there are 2 protons in helium, and if the atomic number is rounded to 4, we always round these to the nearest whole number. If the mass number is 4 and the atomic number is 2, then you subtract them and that will give you the number of neutrons. So there are 2 neutrons in helium as well. Let's have a look at lithium. Now lithium has a 3 up here, so this is the atomic number. That means there are 3 protons and 3 electrons. In order to be neutral, the protons and electrons have to be equal. The symbol for lithium is capital L small I, and the name, of course, is given to you here, lithium. The mass number is written below, 6.941, but we round this to the nearest whole number, so that's 7. So if we want to figure out the number of neutrons, we take the mass number, which is 7, rounded to 7, minus 3, and that gives us 4 neutrons. So this symbol here, all this information can tell us how many protons, how many electrons, and how many neutrons are in the atom so that we can draw the Bohr diagram. Let's lastly look at nitrogen. Atomic number 7, that means 7 protons, therefore 7 electrons, symbol N, name nitrogen, mass number rounded to 14. The number of neutrons will be the mass number 14 minus the atomic number 7, and that will give us 7 neutrons. So now we know how to calculate the protons, the electrons, and the neutrons as given to us by the information in the periodic table. So let's now look at a generalized atom and see where these subatomic particles, that's the name for the protons, electrons, and neutrons, let's see where they go. Okay, so an atom has a nucleus in the middle, and we're going to be putting some subatomic particles in there, and then it has some shells or energy levels. I've drawn this one so that there's only one shell or energy level, but there can be more than that. So in the nucleus, this is where we find the protons. Now protons are positively charged, found in the nucleus, so I'm going to grab this proton and I'm going to pull it down and stick it in the nucleus where it belongs. Neutrons have a symbol, N for neutron, and the 0 means no charge, also found in the nucleus. So those are our 2 nucleus subatomic particles, P plus implying there's a positive charge, and 0 implying there's no charge. Protons and neutrons in the nucleus. Electrons have a negative charge, so I put a little dash there if you can see that, and they're located outside the nucleus in a shell or energy level. So I'm going to take this electron and I'm going to put it right there, and that is how a basic atom would look in terms of drawing a Bohr diagram. protons and neutrons in the nucleus, electrons in the shells or energy levels. So let's go ahead and draw Bohr diagrams for those 3 atoms that we saw earlier on. Okay, Bohr Rutherford diagram for a helium atom. Here is the information that we need. So we see the atomic number is 2. So remember, this means there are 2 protons. So I'm going to take 1 proton and a second proton, put it in the nucleus. Now, let's stay with the nucleus and do the neutrons. How many neutrons will helium have? Mass number of 4 minus 2, that means 2 neutrons. So I'll just grab any 2 of these, put them in there, and that's it for the nucleus. Now, the number of electrons is also given to us by this 2, this atomic number. It means there are 2 electrons. If there are 2 positive protons, there have to be 2 negative electrons. So I'm going to grab the first one, and I like to put it right at the top on this first energy level or shell. Now, when you take the second electron, and there's only 2, you could put it right beside the first one, and some people do that, but I like to stagger these going around in a circle, the top, the side, the bottom, and then the other side as I do this. This then is the completed Bohr Rutherford diagram for a helium atom. There are only 2 electrons. Now, this first energy level or shell is filled with 2 electrons. There's no more capacity for electrons. So as we move up and do more complicated atoms or elements, we're going to have to use extra shells. So let's do that. Let's have a look at lithium. Lithium has atomic number 3. That means 3 protons. So I'll grab 3 of these, put them in the nucleus. Let's do the neutrons. Round the mass number to 7. 7 minus 3 is 4. So take 4 neutrons, just any ones, plunk them down any place in the nucleus. It's going to start getting crowded in there. Let's put it right there. Now, we need 3 electrons because of the atomic number 3. So watch what I'm going to do. First electron in the first energy shell. Second electron staggered like that. Now that energy level or shell is full. I've drawn a second one here, so I'm going to take the third electron, and I like to start right at the top again so that I can go around. There we have the Bohr Rutherford diagram for lithium done. On to nitrogen. Now nitrogen has a lot going on. There's an atomic number of 7, so that means 7 protons. It's going to get very busy in that nucleus. So let me grab 7 of these. That's all of these here. 5, 6, and 7, just making it. Now, how many neutrons do we need? 14 minus 7, we need 7 neutrons. So I'm going to try to just fit them in anywhere at all there. Whoops. Seven neutrons. All right. Atomic number tells us 7 electrons as well. So starting in the first shell, first one goes there, second one goes there. That shell is full. I've got to go to the next energy level or shell. This is the second shell. So I start at the top. There's electron 3, electron 4, 5, 6. So what I'm doing here is I'm placing one at all of the points of the compass. You could say north, east, south, and west. Now I have one more electron to make the 7th electron, and I start again at the top. Just move this over a bit, line them up side by side, and if I had an atom or element with another electron, I would put it beside this one, beside this one, beside this one, and then at that point, that second shell would actually be full as well, and we'd have to have a third. But that's as far as I'm going to go in this tutorial with these atoms. But there is something else I want to show you, and it's on my website. Now, I have a science website, which is called ZeroBio, and the internet address is down here, www.zerobio.com. And if you're a grade 9 or 10 student, I have resources for you, quizzes and games and various animations. If you go to the Student Center and search for the grade 10 course and go into the chemistry section, you can find this resource I want to show you. Bohr Rutherford pizza. Now this is something I made up just for fun for my students, but you're welcome to give it a try as well. Instead of doing an element, we are going to make a pizza here. So let's choose an element to do. Let's say we wanted to do lithium again and make up lithium pizza. I'm going to type in Li, all right, for the symbol. Now, in the nucleus, there are protons and neutrons. The atomic number for lithium was 3, so I'm going to put a 3 there. The mass number was 7. We rounded it to 7. 7 minus 3 is 4 neutrons. So I'm just going to type a 4 in there. And that's how we illustrate the protons and neutrons. Instead of dragging things in, I've just put the numbers. Well, we are going to do some dragging as we make this pizza because we need some pepperoni, don't we? We've got our mushrooms and olives and our cheese. All right. How many electrons do we need? Well, if there are 3 positive protons, we need 3 negative electrons, or 3 pepperoni. So, first pepperoni, electron goes there. Second one goes there. That first shell is full of pepperoni. There's one more, and I'm going to put it right there. All right, so 3 electrons or 3 pepperoni. You can also click on the mushrooms here if you need some help, and this will tell you a little bit of what to do. All right, so I hope that helped you understand Bohr Rutherford diagrams and enjoy that Bohr Rutherford pizza. Thank you for watching.